Consider a number written like 2 to the third. 2 to the third means 2 times 2 times 2. I am multiplying 2 by itself 3 times. So this 3 that right on the shoulder of this big 2 is called the exponent. So this, if I write 2 to the third, this 3 is what gives the name exponent. So it can be called the exponent. It can sometimes be called the index. And it could also be called the power. This big 2 is called the base number. So it is the number that carries the exponent, base number. So writing numbers in exponent form is just a shorter way of writing numbers so that we can work with them when we simplify algebraic expressions. For example, instead of saying 2 times 2 times 2 times 2, then times 2 times 2, we will write it for short that 2 to the exponent of 4 times 2 to the exponent of 2. So this exponent of 4 comes from this first bracket of 2's that are 1, 2, 3, 4 of them, that goes there to that exponent, and then this second bracket of 2's goes to this exponent. Okay, so if we count the whole thing, we have 6 2's in there. 1, 2, 3, 4, 5, 6 of them. So with exponent, instead of writing it out too long, we just write it for short. But then the exponent tells us the number of 2, so we can further shorten it by saying that it has 4 plus 2 2's, so that all of this expression can simplify to 2 to the 6th power. That brings us to the first rule for exponent, which we are going to call rule 1. So rule 1 says that if we have a base number a to the exponent of some number m times the same base number, it has to be the same base number for the laws of exponent to work, times the same base number to some other exponent. For example, like we had 2 to the 4th times 2 to the 2nd. M could be 4, n could be 2, it could be any number. But what the rule is saying is that simply keep that base number and add the exponents. And that is how to simplify those. So this is our first rule for exponent. Let's take some examples that can make use of this rule. Examples. Okay, so you will always see the word simplify means apply some properties of exponent until it is in a form where it is very, very reduced and you cannot apply any more properties. So simplify 1, 2 to the 5th times 2 to the 3rd, 2, 3 to the 4th times 3 to the -7, 3, 5 to the 2nd times 5 times 5. Okay, so based on this rule, we want to keep the base number the same and add the exponent. So the base number is 2, we keep the base number the same here, and then we add the exponent. So we have 5 plus 3. And so we have 2 to the 8th power. Keep the base number, add the exponent 4 plus -7. And so we have the base number is 3. Now we solve this problem here. From our integers, 4 plus -7 is -3. Base number is 5. The exponent here is 2 plus, you don't see an exponent here, but this means 1, 5. So it's just 1, 5. So the exponent is 1. So 2 plus 1, and you have 5 is the base number, and the correct exponent is 3. So this rule is called the product rule for exponent. So it is a rule for multiplying exponents. So product rule. Let's consider that we wanted to divide 2 to the 5th divided by 2 to the 3rd. This is the same as 2 times 2 times 2 times 2 times 2, 5 of them, divided by 2 times 2 times 2, 3 of them. Okay, but then this 2 at this numerator can divide this 2 one time. This 2 can divide this 2 one time. This 2 can divide this 2 one time. And then we don't have any more 2's to divide those. So we now have 1 times 1 times 1, 1 times 2 times 2. So we now have 2 to the 2nd and fraction bar 1 at the denominator, which is just the same as 2 to the 2nd. So this could also be seen as 2 to the 5th. Instead of going all that way around, we can make it shorter, because in math we always want to make things shorter and brief to write. So 2 to the 5th. So there were 5 2's at the top and 3 2's at the denominator. So we ended up with 2 2's at the numerator. So if we just did 5, those 5 2's for that exponent minus the 3 2's at the denominator, we end up with the 2 of them. So we end up with the same thing. So this brings us to our second rule for exponent, which is saying that if we have any base number a to an exponent of m, and we are dividing it by the same base number a to another exponent of n, this is just the same as keeping that base number a and then subtract the exponent. So this is the quotient rule for exponents. Okay, so this is what is called the quotient rule. Now we are going to take some examples to show how we could use this quotient rule to simplify exponents. So let's take some examples. We have the first, we want to divide x to the 5th divided by x to the 3rd. Number 2, we want to divide 2 to the -5 divided by 2 to the 6. We want to divide 3 to the 2nd by 3 to the 5th. And we want to practice this rule a little more to get 5 problems. So also understand that the division sign could be written as a fraction bar. So we want to divide x by x to the 2nd. And the 5th one, we could divide a half to the 3rd by a half to the 3rd. Okay. Let's see how we can use this rule to simplify these problems using exponents. So let's simplify using the quotient rule for exponent. So the quotient rule says identify the base number. The base number is x, and then what do we do here? We subtract the exponent. Okay, we subtract the exponent. So we will subtract the exponents. But what are the exponents? 5 minus the second exponent is 3. So we have that base number x. 5 minus 3 is 2, and yep, there we go. That simplifies to x to the second. So same thing, identify base numbers, keep the base number, subtract the exponent. At the exponent level, we have -5 minus the second exponent is 6. So keep the base number. So this equals, keep the base number of 2. -5 minus 6 is -11. Okay. Our goal here is to apply the property for simplifying exponents. Subtracting integers is a skill that is already required. That is already a prior knowledge for this standard. Okay, so here we keep the base number of 3, and then we subtract the exponent. 2 minus 5. Keep the base number of 3. 2 minus 5 is -3. And you could leave your answer like that for now until we learn another rule for exponent that is going to show us how to rewrite numbers like this. All right, base number is x. That is what we want to do. When we don't see an exponent, the exponent is 1. So we start off with the exponent that comes with the first term. Okay, so the first x has an exponent of 1 minus the second x has an exponent of 2. So keep that base number. 1 minus 2 is -1, and you could leave it like that for now. Okay, you could leave it like that for now. Okay, so here the base number is a half. Keep that base number of a half. It's a base number is a fraction. You could keep it as a fraction. And then the exponent of the first fraction at the numerator is 3 minus the exponent of this denominator fraction is 3. So you get a half, and the exponent is 3 minus 3, which is 0. Okay, you can leave it like that for now, and we will learn another property that may help us to rewrite terms like that.